Today we are going to discuss about the transistor connection. In the last PPT we discussed BJT, bipolar junction transistor, the modes, the active modes, the working modes, the operation modes of BJT. In today's lecture we are going to discuss about transistor connection. So I already discussed about transistor connection in the last lecture, that the transistor connection is having three types. This is known as configurations also. So this is our having three types, that is common base, common emitter and common collector. What is the word means common? In this common, in any operation we need two ports for the input and two ports for the output, but in transistor in total we have only three ports, so we need one more port. So for eliminating this problem we are going to common one port. That means one port should be common in input as well as in the output. So in this, the base, in common base the base should be common in input as well as the output. In common emitter the emitter should be common in input as well as in output, and in common collector the collector should be common in input as well as in the output. So that's why we are having three configurations. First is common base, second is common collector, and third is common emitter. So what is common base? The common base terminology is derived from the fact that the base is common in both input as well as in the output side of the configuration. Then in the first figure, in the first figure the common base NPN configuration, and the second figure shows the common base of PNP. So this is NPN common base, this is PNP common base. So this is base. This base is common in input, this base is common in output. This base is common in input, this base is common in output. So current amplification factor, that is alpha, the ratio of change in the collector current, that is IC, to the change in the emitter current, that is IE, at the constant voltage collector base is known as current amplification factor. That means alpha is equal to IC upon IE. So this is a common amplification factor. What is the common amplification factor? States that the ratio of change in the collector current to that of the change in the emitter current at the constant VCB is known as current amplification factor. So in this figure, this is NPN and the second is PNP. So this base is common in input as well as in output in NPN, and this base is common in input as well as in output in PNP. So you can see now the input characteristics. The VBE is voltage base emitter versus IE is emitter current. Characteristics is called input characteristics. This is input characteristics. This is VBE, this is IE. These are input characteristics, means at 0.6 level the characteristic should be negligible, or you can say that stable, and after that when VCB is when VB is equals to 1 volt, 10 volt, 20 volt, it will shoot up. So in emitter current increases rapidly with VBE, it means input resistance is very small and it is almost independent of VCB. That means when VCB is changes, that means IE is increasing. That means the resistance should be very small, and IE is totally independent of VCB. That means it is dependent on VBE. That means when VBE is increasing, that means IE is increasing. So IE is independent of VCB. So this is the common emitter input configuration, common base input configuration. Now the output configuration. Then VBC versus IC characteristics is called output characteristics. You can see that VCB and this is IC. So this is when IE is 0, that means there is negligible. When 1 milliampere something, 2 milliampere, 3 ampere, 4, 5, 6, 7. So as the emitter, as the VCB is increasing, it will IC is linearly increasing with VCB, when only VCB is very small. When VBC is very small, IC varies linearly with VBC, and VBC increases, IC becomes constant. IC becomes constant. When VBE is increasing, IC becomes constant. This is IE. This is IC should be constant. This at 1 the IC should be constant. At this position, this will constant at the whole. and this one IC is constant at the hole, then IC is constant at the hole. So this means IC is constant and IC and IC is linearly with VBC. So this is the output characteristics of a common base configuration. Now we are going to discuss about the input and output resistance of a common base configuration. Then what is the input resistance? The ratio of change in the ammeter base voltage to the change in the ammeter current is called input resistance. That means the ratio of change of ammeter base voltage VBE to the change in the ammeter current IE is called input resistance. The ratio of change in the collector base voltage means VCB to that of the change in the collector current, that is IC, is called output resistance. So the now next is common emitter configuration. So in the common emitter, the emitter is common at the input and the output. So that's why it is known as common emitter terminology. So in the first figure, this shows the NPN configuration and this shows the PNP configuration. In NPN, this emitter is constant. This emitter is common in input as well as in the output, and this emitter is common in the input as well as the output. So this is known as common emitter NPN and this is known as common emitter PNP configuration. So what is beta? Beta is the amplification, base current amplification. That is what is alpha? Alpha is known as alpha is basically known as the current amplification, and now this is we're going to study about base current amplification factor. So in a common emitter connection, input current is base current and output current is collector current. So input current should be the base current and the output current should be the collector current. So the ratio of change in collector current to the change in the base current is known as base current amplification factor. So by beta is equal to delta IC upon may delta IB is known as current amplification factor. So in the input characteristics, VBE versus IB characteristics, VBE versus IB. So you can see that IB increases rapidly with VB. As the VB increases, IB should be increasing, and VCE, this means input resistance is very small and the IE should be independent of VCE, and IB is the range of microamperes. IB is always in the range of microamperes. You can see that this is IB in the range of microamperes, and as the VB increases, it will increase rapidly and it is independent of VCE. So this is the diagram for input characteristics. Now we are going to discuss about the output characteristics. VCE versus IC characteristics means this is VCE and this is IC. Similarly, the IC should be constant. You can see that the IC varies linearly with VCE. VCE increases, this is increasing linearly. At the same point, at 0 position, the same will be happen at the 15th position. So IC should be constant. You can see that IC becomes constant and VCE increases. That means VCE, as the VCE increases, that means VCE should be increases to 5, 10, 15. This IC should always be constant. You can see that IC becomes constant as the VCE increases. So in this we can see the output characteristics of base, common base and the common emitter. The input and output is similarly equal, but the current should be different. So what is the input resistance and the output resistance in common emitter? The ratio of change in ammeter base voltage to the change in base current is called input resistance. And what is the output resistance? The ratio of change in collector ammeter voltage to the change in collector current is called output resistance. So input resistance is equals to VEB upon may VB, and voltage resistance is equal to VCE upon may IC. It's called output resistance. So now the next is common collector. So the common collector terminology is derived from the fact that the collector is common to both the input as well as the output side of the configuration. And in the first figure, this will show the NPN and the second will show the PNP. In this, collector should be the common. The collector should be the common in input as well as in the output. So if in the current amplification factor, that means gamma, in common emitter connection, input current is base current and output current is emitter current. So base current is the input and output current is the emitter current. So collector should be the common. The ratio of change in the emitter current is to the change in the base current. Emitter current is the output and the base current is the input. So the change in the base output current, that means emitter current, to the change in the input current, that is the base current, is known as current amplification factor in the common collector configuration. So these are the characteristics, like in a common base, common emitter, common collector, the input resistance should be low. The input resistance is only high in the common collector, the output resistance is low in the common, high in the common emitter, and very high in the base, and voltage gain is almost equal, less than equal 1 in common collector, in equal to 500 is a common emitter, and about 150 is no in the base. So in common base it will use for high frequency application, common emitter is basically used in audio frequency applications, and common collector is basically used in the impedance matching, and the current gain is less than 1 in the common base, is high, is always high in the emitter, and it is appreciable in the common collector. So in this slide we discussed about the BJT, the configurations used in the BJT, and the configurations are common base, common collector, and common emitter. We already discussed about the value of common in this lecture, in this common base, collector, and emitter. So the output characteristics of common base and common emitter is similarly equal. In this, IC should be same. In common base, IC should be constant, but as well as in common emitter output characteristics, IC should be constant. So the output characteristics of common base and common emitter should be most probably equal. So in this by this PPT lecture, the BJT is almost over. Now in the next slide we are going to discuss about the Mosfet. So Mosfet is basically known as metal oxide semiconductor field effect transistor. So this is used in many applications. We are going to discuss in a detailed manner in the next slide. For today we already completed the BJT, FET. Now the next is Mosfet. After that the transistor should be over. So thank you.